Okay, so to finish that up, so we would go to stat, we'd arrow over to calc, and normally, so just to show you in your calculators, if you go to stat and then arrow over to calc, in algebra 2, you guys pick number 4, ax plus b, because that's in the form of slope-intercept form, y equals mx plus b. But statisticians, we like to pick number 8, a plus b x. 8, which is ln reg a plus bx. And then you'll just go down to calculate. And when I do that, since I already have diagnostics on, it is going to give me my R value. So I already know that my R should be 0.050, rounding to 3 decimal places. We'll talk about the equation more tomorrow. But just so you know, just in case you don't see the word calculate, when you went to stat calc number 8, you may not see this menu. So if you don't see that menu, you may see something like this. So let me arrow up and go grab it. So you just may see ln reg a plus bx. Just hit enter, and you're going to get the same thing, right? 0.050. Okay, so let's go ahead and talk about the properties of a correlation coefficient in the PowerPoint. So you can see what are some things that we'd expect you to do with that. So the properties of a correlation coefficient is that it has to be a legitimate value. The only legitimate values accepted are in between -1 to 1, where it could equal exactly -1 or 1. Okay, so both of those are okay. This is also where we're going to talk about the strength. So if you end up getting a correlation coefficient of exactly 0, that just means there's no correlation. Okay, if you get a correlation coefficient somewhere between -0.5 and 0, or 0 and 0.5, so anything between the 0 to 0.5 range, whether it's positive or negative, you're going to get a weak correlation. All the positive or negative means is positive or negative relationship. Okay. Moderate is going to be between 0.5 and 0.8, or -0.8 and -0.5, just whether one's positive or negative. And then your strong correlation is going to be somewhere between -1 and -0.8, or 0.8 and 1. Okay, so if it's above 0.8 or below -0.8, it has a strong correlation, just whether it's positive or negative. And if it has a correlation of 1 or -1, that means it's a perfect correlation. Okay, that means it's perfectly linear. Because once again, we are only talking about linear relationships. So if we had like a correlation of like -0.73, well, since it's negative, it'd be a negative relationship, and 0.73 is in the moderate range. So it'd be a negative moderate linear relationship. So these ranges you do have to know for your quiz and test. The interpretation of the correlation coefficient, you'll always say that there's some sort of strength relationship. So whether it's weak, moderate, or strong, remember weak's between 0 and 0.5, moderate's 0.5 to 0.8, and strong is 0.8 to 1, not 0.1, so 0.8 to 1. Positive means the sign was literally positive, negative means the sign was negative, and then you need to say the word linear relationship. Okay, you have to tell us that it's linear, and then make sure that you tell us X, Y in context. So for the example above on page 2, you would say, instead of saying between X and Y, you would say between expenditures and graduation rates. Okay, so that's what we mean by context. You can't just always say X and Y unless it literally is just X and Y. Okay, so going back to our expenditures and graduations rates, another property of a correlation coefficient is sometimes values are mistyped. So let's say that 33.9 was really 63.9. Okay, so if we actually fix that, we need to talk about what's going to happen to the correlation coefficient. So if we went back into our calculator to plot a revised scatter plot, so it's pretty much going to be the same exact scatter plot that we have, except the last point is going to go up. Okay, so that last point of 8,248 is going to go up. So to show you that, this goes up. Okay, and what happens with your correlation coefficient? You get 0.423. So did that make the relationship stronger or weaker? So if we're going from 0.05 to 0.423, hopefully you're telling me that the relationship got stronger, because that is true. Both are still positive, but they are getting a stronger relationship if we fix that mistyped value. So changes to even one data point can significantly affect that correlation coefficient. And we'll put that in our notes on the next page when we sum up the properties of a correlation coefficient. So then the last one, let's go ahead and find the correlation coefficient for these points. So you need to type your X values into L1 and your Y values into L2. Remember, if you ask me, you should be practicing this in your calculator. If you ask a calculator question on the quiz day, test day, or final exam day, there is no help given for that. So type your X's into L1, your Y's into L2, and then you're going to calculate your correlation coefficients. Remember, the way we get there is stat calc number 8. 30 more seconds to do that. Okay, so that should have been enough time. So the correlation coefficient you should have gotten is 0. There's no correlation between those values. Okay, so does that necessarily mean that there's no relationship? No. Okay, if you actually hit zoom 9 on your calculator screen, you will see that it actually has a parabolic relationship, a quadratic relationship, but it's just not a linear relationship, which is the only one that we're interested in for this unit. So let's go ahead and sum up all these properties for the correlation coefficient on page 3 in your packet. So on page 3 in your packet, we are going to look at all 3 of these properties that I just talked about. So the first one, legitimate values. Okay, you have to have between -1 to 1. Okay. Number 2, the value of the correlation coefficient is affected by extreme values. And we'll talk about different extreme values that we can have, such as outliers or influential points. So we'll talk about those in this unit. And the value of R is a measure of the extent to which X and Y are linearly related. So I need you guys to remember this correlation coefficient is only for linear relationships. Okay, it's only linear relationships. It does not tell us anything about quadratic, exponential, cubic, anything. It's only for linear relationships. So those are the properties that we will be keeping in the back of our mind for this 3-day lesson unit. So to sum this all up, we're going to go ahead and go back to our correlation coefficient that we looked at for our expenditures and our graduation rates. So we already found that the correlation coefficient was 0.05, but then they can ask you to interpret it. Remember, this is our nice little prompt that we had on the page 2, right? So we are going to say that there is 0.05 is in between 0 and 0.5. So that's a very weak relationship. So we're going to say that there is a weak relationship. Then once again, since the correlation coefficient is positive, we'd say it's positive. And then you need to tell me it's a linear relationship between the context, X and Y. So to show you that, we would say that there is a weak, positive, linear relationship between expenditures and graduation rates. And that's a sentence you'll definitely be writing on your quiz and test because, of course, we're going to have some short answer. So make sure you know this prompt and make sure you know to include weak, strong, or moderate, positive or negative, linear relationship between X and Y in context. Okay, so does a value of R close to 1 or -1 mean that a change in one variable causes a change in the other? So this is going to be a big concept you have to know. For example, the relationship between the number of cavities in a child's teeth and the size of his or her vocabulary is strong and positive. So they're saying that there was a relationship here. Okay, so does that mean that you should feed your children more candy to increase their vocabulary? No. Okay,